Welcome to Probability and Stats. Let's get started. So for this video, we're going to cover the definition of probability and we're going to hit some multiple event probability questions. So when we talk about probability, we are talking about the likelihood an event will occur. In math, we can calculate that likelihood by just attaching numbers to the chance of something happening, either a percent, fraction, or decimal. Probability is the likelihood something will happen, not a guarantee that something will happen. So when rolling dice, you could roll a die 5 times and get 5 sixes in a row. It's unlikely, but it's possible. And with math, you can calculate what that likelihood is, and this can apply to almost anything. Getting really good at probability and stats will obviously help you with the DAT, but it's arguably the most beneficial math topic that can also wildly impact your life. If you can get really good at probability and stats, your ability to make good decisions will increase exponentially, and I could probably spend all day talking about that. But that is not why you're here today, so let's talk about math. So when talking about the probability P, something will occur, that is always represented with a number 0 to 1, where P equals 0 means that there's no chance the event will occur, and P equals 1 means 100% chance it will definitely occur. So when we flip a coin, we know there's a 50% chance to get heads and a 50% chance to get tails. But how do we know this? We know that with this equation. Probability equals the number of desired outcomes over the number of possible outcomes. So if you're looking for heads, the numerator, the top number, is 1, and how many possible outcomes are there? 2, heads or tails. The probability of flipping a coin and getting heads is 1 over 2, or 50%. The end goal with all probability questions is to find the number of desired outcomes and the number of possible outcomes. That's it. Then you do some level of basic math, which we'll get into in a minute, to figure out what the actual probability is. Keep in mind that desired outcome does not mean what you want to happen. It just means that's what the criteria is that you're looking for. So example number 1, we have a bag of 100 marbles, 20 red, 20 blue, 25 green, 25 yellow, and 10 orange. If a marble is grabbed out of the bag at random, what is the probability that you grab a yellow marble? So if you already feel like you know how to do this one, pause the video and solve it. I've got that probability equation there for you too to work with. All right, here's how I would do it. So we're looking for the probability that we grab a yellow marble. In the question, it said that there are 25 yellow marbles. So the number of desired outcomes is 25. And then you divide it by the possible number, which is 20 red plus 20 blue plus 25 green plus 25 yellow plus 10 orange, which comes out to be 25 over 100, or 25%. All right, what if we have the same situation, but now we want to know what the probability is of grabbing a red, blue, or orange marble? Our desired outcome is 50, and our total number of possible outcomes is still 100, just like the last question. So we add up the thing that we're looking for, which is 20 red plus 20 blue plus 10 orange, which is 50, and you divide it by the 100, that's the total, to get 50%. So we have a 50% chance or a 50% probability that we will grab a marble that is red, blue, or orange from this bag. Now what about the opposite situation? How would you solve for finding what the probability is for an event not to occur? It's just as easy as finding the probability that something will happen. So there's 2 ways that you can think about this. Option 1 is to do the problem the exact same way as before, except now the desired outcome is every outcome except the one event discussed. So for this example from earlier, what is the probability that you grab a marble that is not red, blue, or orange? We could just count all the other options, green, yellow marbles, and divide that number of desired outcomes, 50, by the total number of possible outcomes, 100. No problem. The second way to solve this is recognizing that the probability of an event to occur plus the probability of the event not to occur is 100%, meaning it equals 1. It either happens or it doesn't. There's no other options. That also means if we know the probability of P happening, we can arrange this equation to tell us the probability of P not happening, which I'm representing that as P negative. So rearranging that equation, you get P negative equals 1 minus P. What if we use this scenario, but instead I ask what is the probability that you grab a marble that is not blue or green? We can see the probability of grabbing blue or green is 45%, or 0.45, however you want to represent it. And the way that we got that is 20 plus 25 over 100. So the probability of not grabbing blue or green must be 1 minus 0.45, or 1 minus 45%, to get 0.55, or 55%. All right, we're cruising right along here. So far, we've only talked about single events, either an event happening or not happening. Now let's talk about multiple events. Things like what is the probability of two things both happening and the probability of at least one thing happening. So first, let's define a couple things. Mutually exclusive means both events are unable to exist at the same time. For example, you pull one single marble out of the bag with yellow and blue marbles. You can either pull out a yellow marble or a blue marble, but you can't pull out both. Those outcomes are mutually exclusive. Independent events are when two or more events are independent of each other, or when they have no influence on each other. For example, flipping a coin over and over and over again does not affect what's going to be flipped next. So each flip is independent of the previous flips. And then the last definition here, sample space, is the set of possible outcomes. All right, now let's talk about multiple events. In the earlier problem, we had 100 marbles of different colors, and we added them together to discover what the probability is of picking either a red, blue, or orange marble. When working with mutually exclusive events like this, which will be almost every time on the DAT, and you're finding what the probability is of one or the other thing happening, you add the probabilities together. So if we weren't given the number of marbles of each color, and we're only given the probabilities, say 25% and 25%, then we can just add those probabilities together to find what the chances are of picking one of those colors. Now, what about finding the probability that both events will happen? We multiply them together. And side note, I would suggest memorizing this slide. Knowing these two things and how to apply them will cover a huge chunk of the stats topics. All right, this equation we're showing here is called the addition rule of probability. Finding the probability of A and the probability of B is easy, and then the probability of A and B is just multiplying them together, like we just said with that last definition. So if a question ever asks you for the probability of at least one event occurring, at least one, then this is the equation that they want you to use. Alternatively, you could also do this. If it's easier to find the probability that none of the events A and B happen, then you could just do 1 minus that number, and that will also give you the probability of at least one thing happening. But generally, they're going to ask the question in the format that will give you that first equation. But generally, they're going to give you the question in a way that you'll want to use that first equation. All right, here's what we covered today. Number 1, how to find the probability of an event. Number 2, when two events are mutually exclusive, you can find the probability of one or the other thing happening by simply adding them together. Number 3, the probability of an event not occurring is 1 minus the probability of it occurring. Number 4, the probability for both events happening, just multiply them together. And number 5, to find the probability of at least one event happening, use this equation. Take a screenshot for your studying, and I'll see you in the next one.